Welcome, everybody. We know that there will be a few more people coming on in because this is Berkeley, and we have what's called Berkeley time, which means that everything starts somewhere exactly between on the hour to 10 minutes after the hour. But if we want to have as much time as possible for the discussion that we're going to have today, it's a real pleasure to welcome our panelists to UC Berkeley and to be in a position to hold a conversation that relates to the future of advanced nuclear energy and ideas for how it is that we can accelerate the innovation development in this field of technology and reestablish leadership here in the United States via innovation. I'd like to thank people who've contributed to organizing this day. It's filled with a bunch of different activities, which includes at 4 o'clock a talk that we're going to keep Dan very busy, View from the Top Talk. But I'd also like to thank the co-hosts for this panel session, The Third Wave, co-sponsor. We have Susie Baker here, and Josh Freed has played an important role. We will summarize results and discussion, and we're recording this discussion because we think that there will be a number of very important ideas that will come out of it that can be summarized and made available and point in directions for future federal policy. I'd also like to thank the College of Engineering for helping us to put together these events. Jane Anderson has worked very hard, and we have right here in the audience also Randy Swearingen, who's also been an amazing supporter for the department. I'd also like to thank the members of the department who helped put these things together, and in particular Sarah Harmon and Christina Castellanos, and they've really done a lot of work to get us here. And then finally, we have a set of students who've been escorting people around, who will be conducting open house tours of laboratories and stuff. And they also, I'd like to thank them for their service. So this is a panel session. We're going to start with some just brief remarks from each of our panelists. We've really collected an amazing set of people together to discuss the topic of how we can accelerate the advancement of nuclear energy, and moreover, to look at analogies between NASA, SpaceX, commercial space, and advanced nuclear as well. It's an auspicious time. Last week, for the first time in history, we had a company successfully reuse a first-stage rocket, saving about $60 million worth of equipment. Over this last decade, we have reestablished U.S. predominance in commercial space launch, which had essentially entirely exited the country. This week, SpaceX announced that it's hiring 500 new engineers because they need them. This is a success story that we should see replicated across all fields of advanced technology, including nuclear. That's really the goal here. So what I'd like to do is just briefly name and give affiliations for our panelists, and then we'll take about 3 to 4 minutes each for some comments, and then we'll move to questions. Dan Rasky is chief scientist for NASA Ames and the Space Portal. He's an amazing person. He's got these great videos on YouTube. I credit NASA for capturing that knowledge. Rita Baranawal is the director of DOE's GAIN program, Gateway for Accelerated Innovation in Nuclear Energy. She has the same job as Dan, except she's 10 years later in this process. And 10 years from now, when we bring her back, it should be entertaining. Rachel Slabaugh, our professor in our department, she is one of the people that envisioned and created a boot camp that we've held here on nuclear innovation, and we'll be holding again this next summer. And she also might end up at a federal agency in DC at some point if we continue to have an ARPA-E program. Jose Reyes is a co-founder of startup company named NuScale. He's a hero to anybody who works in thermal hydraulics because he's proven that you can be innovative. And his company actually just recently submitted design certification application for the NuScale power plant. And then Carolyn Cochran, she's also just a pretty amazing person, COO of this company named Oklo, developing microreactors, extraordinarily innovative and exciting technology, and we want to welcome her. And then finally, Edward Blanford, he's one of my former doctoral students, so he's always nice to me. Almost actually, he will question me on a routine basis. He's great.
Now that he's graduated.
He's now the Chief Technology Officer for the youngest startup company represented here in the room, which is Kairos Power. With that, we've introduced the panelists, and I'd like to turn the floor over and ask Dan if he could just give us some introductory remarks and perspective, and then we'll move down through the rest of the panel.
Sure. And first, I'd like to thank Professor Peterson for inviting me here today. And just briefly, a little bit of my background. I'm a space guy. I work on heat shields. So what am I doing here? And that's a valid question. And Professor Peterson mentioned these YouTube videos that are up online. Actually, NASA did as part of a knowledge capture project, and they really did do a good job, actually much better than I had anticipated. And I have to say one funny thing. It's the first time my millennial children found out something I was doing from their friends, because they saw these YouTube videos from their friends, and they said, "Is this your dad?" And it turns out it was their dad. So anyhow, as a proud father, so yeah. Anyhow, but the reason that I'm here is that these YouTube videos, apparently Professor Peterson and some of his colleagues came across them, and I was talking about my experiences with SpaceX and about essentially the disruption of the civilian aerospace industry that both SpaceX and now Blue Origin and even United Launch Alliance are undertaking, and the role that we played at the Space Portal, myself, my colleague Bruce Pittman, who's here, and others in helping to make that happen. And so it's been quite an interesting experience. We had some nice discussions looking at the overlap and similarities between the traditional aerospace industry and I'll just say the traditional nuclear power industry. And civilian aerospace was really ripe for disruption. Elon made that happen. And there's elements or indications that nuclear power may be ripe for disruption. I guess we'll see in the 10 years that come. But let me turn it over to Rita with that.
And let me just quickly note, because I had neglected to mention, students are handing out cards. Please go ahead. We're going to curate questions for the panel. Please feel free to write down questions on the cards, and then we'll be collecting them in a little while. So that we can pose a set of questions to the panelists afterwards.
I'm Rita Barenwall. I am the director of GAIN, as Per mentioned. Thank you for having me. Little quick background on me. I have been in the nuclear industry for 20 years, doing innovative research and development for almost all of it. So innovation is in my blood. Doing things a little differently is very first nature to me, so much so that many of my mad scientist type of hands-on experiments, I was relegated to conducting them at midnight because they were a little risky. And actually one resulted in a 4-alarm fire. So, but also resulted in a startup company. So I understand about innovating and doing things a little bit differently. So about GAIN. GAIN was launched in November of 2015 after receiving a lot of input from nuclear technology developers, industry, government, and academia, and realized that there was a need to pair private industry with the capabilities that were available at the United States National Laboratory Complex. There's a lot of unique capability, unique experience, and unique data that is housed in this complex that traditionally has not been accessible for various reasons. So DOE launched the GAIN initiative over a year ago to make sure that those that wanted it could get access to the technical expertise, get some financial assistance if needed, and then also get some regulatory guidance to help navigate their way through the Nuclear Regulatory Commission's policies and licensing processes, which are actually trying to be tailored and streamlined a bit more for the advanced reactor and advanced technologies that are coming up because the current regulations aren't going to be applicable to these new technologies. So my job is to make sure that those that want it get introduced and get educated on the capabilities that we have in the DOE complex, that we initiate relationships, that we provide some funding, some in the form of vouchers, which you'll hear hopefully about in a moment, and make sure that we, in the DOE complex, help industry get to market faster.
So I'm Rachel Fleiba. I'm an assistant professor here at Berkeley. My technical area is computational methods for neutron transport. So I sort of build tools that other people use for design and analysis. But I'm here because I started the Nuclear Innovation Boot Camp, and some of the people in this room helped plan and run and execute the first one, and we're in the process of doing the second one, which will be at the end of July this year. But that all started as a result of the creation of GAIN. So GAIN was started, and in a discussion about how do we help ensure that GAIN is successful, what do we need to do to help these companies succeed, in sort of backing that up, I kind of got back to, we don't necessarily, as educators, have curriculum that really asks students to think differently or innovatively or challenge the norms or be prepared to go to startups or be prepared to really take new challenges. And some places do that a little bit, but by and large, across nuclear engineering, that wasn't really what we were doing. So I started the boot camp as a way to start bringing those kinds of discussions and ideas to nuclear engineering students and ultimately young professionals. This year, we're welcoming early to mid-career professionals from companies as well to come participate. The idea being, if we really are going to do things differently, we need to start thinking differently and not just plan to continue having the model that has been working the way that it has been working, and really giving people the tools and sort of the opportunities and the insights and the connections to challenge how things have been done so that we can actually gain some of these improvements that we really are looking for. And so that's most of why I'm here. And then as a result of that, I started talking with ARPA-E, which is an agency inside of DOE, an office inside of DOE that does sort of moonshot clean energy research, and they're interested in starting a nuclear program. And so if ARPA-E continues to exist, I will probably go run that program.
Very exciting. So I'm Jose Reyes. I'm the Chief Technology Officer and co-founder of NuScale Power. Started the company, actually it started as a project at Oregon State University in 2000 to develop a small modular, a multi-application small light water reactor. And we did that work, and by 2003 we had a great design concept, and was very excited about that. I realized at one point, I was on a sabbatical at the IAEA in Vienna, that there was a real market for this. That there were many countries that had smaller grids, couldn't afford the 1,000 megawatt type reactors, and there was a big market for this. So entered a commercialization program in 2005, and I tell people this all the time. I thought to myself, I'm going to take it from the lab to the market. How hard can that be? It's really hard.
Famous last words.
It's a lot of work. But it's been amazing to see the company grow and where we are today. I think at the peak of our work on the design certification application, we had about 800 people working on the project. We've expended over $550 million to get to this point. Our DCA was submitted here in January, 12,000 pages. Yeah, 12,000 pages. But also, we also submit all of our topical reports and technical reports, all the supporting information. But sometimes that's not done, and that's an important part of having a complete application. So those were submitted. It was, I think, 14 topical reports and 17 technical reports. We spent about $12 million in pre-application with the NRC, and it cost us about $12 million in NRC fees to do that. We expect that, well, we have been docketed now in 60 days, so I think that's unusual to get docketed in 60 days. That's lightning speed. So what we expect to hear now is a letter from the NRC saying that it'll probably take about 40 months to complete the review, We expect to spend another $40 or $50 million associated with that review. And in the meantime, we're working with the customers. So the Utah Associated Municipal Power Systems is wanting to build a new scale plant at the Idaho National Laboratory. So DOE has been instrumental in getting the site use permit for that facility, as well as the matching funds that has gotten us to this point. So DOE is providing us with $217 million in matching funds. And up to this date, it's about $360 million from Fluor, our parent company, and about $160 million from DOE. So this is the last year that we have on the DOE funding. So we are looking to see what the next steps are with DOE, with the new administration, and we're also working with our customer to see what we can do for that first plant to reduce risk. And I think we'll talk about that some on the panel.
All right, I'm Caroline Cochran. So I'm from Oklo, and a little bit about me. I was a mechanical engineer who did entrepreneurship in the early 2000s and throughout my undergraduate career, and started a business development program. So it was a little bit of a shock to me when I went to MIT in grad school for nuclear engineering, how different the perspectives were. You know, in undergrad mechanical, I had classmates that went to Tesla and SpaceX as kind of early employees there, so it was very interesting to hear their stories versus where I was in graduate school in nuclear engineering and how academic the field tended to be. And that is where I met my co-founder, Jacob DeWitt, who's here in the audience. And we co-founded Oklo Inc. We were first called U-Power, but our goal was to build a reactor that had a clear customer set. And what we found was that people were very interested in microgrids. So we developed a reactor that's between 1 and 2 megawatts electric, and we've been working with several interested customers. And we're actually the first advanced reactor, non-light water reactor, to begin formal pre-licensing process with the NRC, which has been very interesting. I think we can offer insights from a variety of different perspectives. We were one of the first GAIN small business voucher recipients, so we've really enjoyed the GAIN process and all the results that we've gotten out of that. And also, as a reactor company, we've been focused on being a leader within licensing process. So we've been the chair of the Fast Reactor Working Group. We've also led the industry task force on stage licensing. And one of our goals, in addition, obviously, to building one of the first non-light water reactors, is to help educate the community at large about what we've seen so far in the licensing process and what would benefit, we believe, all advanced reactors. So that's a little bit of a background about us.
Great. My name is Ed Blanford. It's a bit of a background as well. I'm actually from the nuclear industry working with steam generators. I was a project manager at EPRI for many years and decided that I very much enjoyed two-phase flow and light water reactors, but really wanted to get more involved in more innovative design concepts. And so I went back, and as Karen mentioned, I did my doctoral studies here and got hooked on molten salts and molten salts as a coolant. After doing a brief stint at school across the bay, which we won't name, I ended up at the University of New Mexico, where I currently am an assistant professor, where I'm actually on leave currently. During that time period, I worked extensively on what we call fluoride salt-cooled high-temperature reactors, or FHRs, and I'll talk a little bit about that in a second. But a bit like what Jose was referring to earlier, there's a time period for innovation in nuclear that can be done at the university scale, and there's a lot of good ideas that come out of it. And actually, DOE put a fair amount of money in developing FHR technology. I think the number's almost about $20 million for university programs, which is quite substantial. But there was a recognition earlier this year that the point for continuing this work at the university probably had met its course. I think there's still a lot of opportunities to help support the technology, but ultimately the amount of work that can be done to get it into really a more mature design phase had sort of run its course. And so Kairos Power, which is newly incorporated actually at the end of last year, we're located locally here in Oakland, and then Jack London Square. We started co-founder Mike Lawfer, CEO, and I'm the Chief Technology Officer. The technology, FHRs, for those of you who don't know, combines high-temperature coated particle fuel from the gas reactor community with the molten salt coolants, which come from the MSR program from the old 1960s Oak Ridge days. And we're trying to drive high-temperature gas cycles. So we're I know many of the students here have heard Per talk about this extensively, but the goal there is to effectively drive open air Brayton cycles. And there the hope, the market opportunity for Kairos is to be able to deploy high temperature or high efficiency baseload power, but also to be able to address peaking demands and to be able to provide effectively the ability to do higher efficient peaking. And so that's the opportunity, and I'm excited for the conversation today.
Excellent.
I'm going to make a super quick note that I forgot to say at the beginning. If you are a Twitter person, if you're tweeting, our hashtag is accelerating nuclear, so accelerating nuclear, tweet it.
Okay. I'm way too old.
Per will get right on that.
I just barely got onto Facebook. So this is wonderful. So the students are collecting questions, and we'll start organizing them. I think I'd just like to start out with seeding some discussion, asking Dan Rasky if he could tell us a little bit about what the potential could be for reducing cost for technologies through this more innovative pathway and commercial development, because I think it may not be that widely understood why it's possible to disrupt technologies by doing things differently.
Yeah, I can give actually a documented example that we have from the SpaceX development. And there was actually a colleague of ours who ran the Office of Strategic Formulation out of NASA headquarters, Dr. Rebecca Spike Kaiser, and she wanted to do a cost comparison on what Elon spent to get through the second flight of the Falcon 9 compared to a more traditional government contracting approach. And we actually have a costing model at NASA. It's called NAFCOM. That's NASA Air Force Costing Methodology. So that's our formal tool for pricing out the cost of doing developments. And at the time that they were doing this assessment, we knew that Elon had spent a little under $400 million on SpaceX up through the second flight of his Falcon 9. And so when they ran the numbers through NAFCOM, they came up with a number of just shy of 4 billion. So a factor of 10. And they couldn't believe it. I couldn't believe it. And so the first thing they did, they went back and said, well, hold it, how come, factor of 10 difference, how can this be? They said, well, Elon is actually using commercial practices, not standard cost plus contracting. In the model, you can actually switch over from standard contracting to commercial practices. They did that, and they got the number down to 1.6 billion. They're still a factor of 4 off. So they actually sent a costing team to SpaceX to observe how they operate. How are you operating? How are you managing to have so much productivity? And after watching how they did their supply chain control and their design process, they were able to go in and make other changes to the costing model and get it down to 583 million. So it was just astonishing to a number of people, this cost differential. And we had one other example. There was actually a commercial space activity that developed that's called the Space Hab. And this is a logistics model, a module that flew in the space shuttle. And there we've documented a factor of 8 cost savings. So, I mean, you're looking at large deltas in costs from standard government contracting and approaches to effective public-private partnerships. And I should stress that because for both the Space Hab and for SpaceX, these were public-private partnerships. In other words, the government working effectively with private industry to produce a desired product. But those give us some of the range of numbers that we've seen on the cost effectiveness of public-private partnerships versus a government standard contracting.
Excellent. So I'd like to then pose another question, and then probably I should get the questions coming up here from the audience. So I'll ask James and Joey to go ahead and bring them on up here. The other key set of questions that we face is how do we demonstrate new reactors actually in the United States, as opposed to ending up having them built elsewhere, right? And I just like to ask our 3 executive level people from startup companies, if you were to list one or two of the top challenges to being able to build reactors here, what would you ask us to focus on in terms of trying to reduce the barriers and reduce the risk? Maybe, Jose, if you could.
Sure, yeah, I'd be glad to talk about that. And we're working on some of these things right now. So NuScale is part of the SMR START program. The idea there is that when you're building the first of a kind, that first customer is looking for some risk reduction, some guarantees. And so you're trying to develop a model which allows your product to be competitive with all the other forms of power generation. So they're looking at natural gas, for example, at UAMPS. And they're saying, well, how does NuScale power compare to the levelized cost of electricity for natural gas? Well, those prices will fluctuate, and of course they can't get a guaranteed contract for a very long period of time on the price of natural gas. And that's one of the reasons they started looking at nuclear. But where we are now is we've submitted our application. Now we're building our supply chain. We're getting that manufacturing base established. And we're working with the customer on and with the government to find out, well, how do we take this now past the licensing into commercial deployment? And so that's going to require several things. We want to see the 50-50 cost share that we've had with the Department of Energy continue past licensing into commercial deployment, because that, we think, is what's needed for a first of a kind. Production tax credits. Some of the benefits that have been provided to renewables, would be great to see those also apply to nuclear. The Energy Policy Act of 2005 did allow for production tax credits. We'd like to see that extended beyond 2020 to 2020, to further out to allow us to apply for those production tax credits. Power purchase agreements, that's a big one. DOE did a great study, and I haven't gotten through all of it yet. This is Kutak and Rock, and it's basically purchasing power produced by small modular reactors. Federal agency options. It's kind of a guide to federal agencies on how to develop PPAs for SMRs. So I would encourage everyone to get a copy of this and read about it. This is just the first few pages of the document. But that power purchase agreements, having a federal customer is huge. That would be a great benefit to us. And so when we talk to UAMPS, and because it's on the Idaho National Laboratory site proper, potentially there may be an opportunity to provide power to the lab as well. How does that work, and what are the options there? Loan guarantees, those need to be extended to go out and beyond where they are now. So that would be beneficial. The states can also do things. There's a construction work in progress in which they're able to recover some of the costs while the construction is ongoing to reduce the interest rates for loans. So states can also get involved. But I think it needs to be a holistic project, a holistic program that now enables the first movers and the first customers taking those risks to kind of reduce that risk in a way that's meaningful.
Yeah, I'd echo a lot of what Jose says. If I had to pick two things, I'd pick two broad stroke items and then a whole bunch of little ones. The first of the two big things is really the market forces, right? Like Jose said, right now nuclear is competing against cheap natural gas. It's no big secret, but there's also a lot of ways in which baseload sources are disadvantaged against renewables or various intermittent sources, exactly when we should be incentivizing them, especially as we don't have the kind of backup sources deployed on the kind of scale that we would need to really implement intermittence, like wind or solar on a broader scale. And then the second big thing is the culture, really, of nuclear power. I think due to decades and decades of history of waiting for the government to do something, there's still a long legacy of that, where there's waiting for the government to develop something instead of doing it on their own. I think what you see here is a bunch of change there. But it's still hard for us, for instance, to hire the right people who have the attitude of, okay, I'm going to figure this out, and I'm going to go research this, and I'm not just going to try to figure out what everyone else did before this. And I'm sure that that's kind of similar to what Elon did with SpaceX, is they didn't necessarily source the same parts from the same suppliers that had long lead times and very expensive ways of doing things. They did it in new ways and were very scrappy. So finding that scrappiness in nuclear and just getting nuclear into this new mindset is a huge battle, and that ranges from the industry, academia, the government, DOE, and I know Rita's working on changing that with GAIN, and so it'll be interesting to see how that kind of changes. And then as far as getting into more nitty-gritty of like how the licensing process could change or things like that, I think one of the things is we're hoping that the government, instead of basically pushing a certain technology, will create pull. So that's what we're talking about here is can DOE or GAIN help create an actual market that wants to buy these things instead of trying to dump billions of dollars into a technology without first helping create the right market conditions. So that kind of pulls together both of the two big items. In the licensing process, there's kind of a lot of little things and export controls and all kinds of things that really hinder progress in nuclear. It's very difficult to hire people in nuclear. You know, we're in Silicon Valley, for instance, our company is. There are people from the best and the brightest from all over the world come there, right? But for us as a nuclear company, we can't necessarily do that in the same way. It's so hard to hire from certain countries. It's hard to source things from different countries, and it's difficult to export to different countries. Looking at the licensing process in a new way is another thing. People are talking about different ways of doing that, but one of the biggest ways of looking at that might be, you know, maybe it might actually be a quarter or more of NuScale's process to get the ACRS review, and it might actually double our NRC review time to do the ACRS review. So looking at innovative ways of doing that might also be really beneficial from the NRC side. So those would be some of the big things we're looking at.
I don't know if I have too much to add. I would just say, in the spirit of today's conversation, I think the role of demonstration is important, and many people like to start with prototypes and work their way up. And in the context of regulatory space for nuclear, to do a test reactor basically requires you to go through what we would consider a Class 103 or a Class 104 license, which for non-power reactors, one path. The sad thing is Class 103, Class 104 refer to sections from the 1954 Atomic Energy Act, and it's kind of crazy that we still use statutes and laws from 1954 to enable new technologies. And so while people will say there's a path forward for doing that type of a demonstration, there needs to be a fresh scrubbing of the way that we interpret how we can demonstrate small-scale reactors. And unlike my two colleagues here who have shrunk the size of the technology, we still need to be able to demonstrate perhaps slightly larger nuclear power plants at smaller scale. And right now that framework is really not realizable, and it hasn't really been looked at very closely. And so I think revisiting those rules and understanding how to practically implement them, I don't think any other high consequence engineered system is regulated in that manner, and I think that would be an important place to start.
Excellent. So I have an amazing set of questions here. And I can promise that we could spend the entire afternoon in conversation. So I'm going to try to hit some highlights, and I will apologize because it's not possible to get all of them. But there's a question here actually for Rita. There's a couple that I'd like to bring in. One of them actually is kind of a sad question because we know that the big incumbent firms have been struggling, and in fact, Westinghouse just this last couple of weeks entered into bankruptcy because they've been put underwater by cost overruns in trying to build large light water reactors. And the first part of the question is what's this going to do to impact the future of nuclear energy in general? I'd like to ask Dan also to speak a little bit, to go back in history and think about what it was like in 2006 when the space shuttle might have been your Westinghouse, and there was a question of what was the nation going to do, what would the future look like? And then the other part of the question for Rita is, it would seem that GAIN became needed because DOE lost interest in innovation and in discovery. Do you agree? And if not, if so, should we seek to change this or let private industry continue to lead? Those are the couple of questions. Dan, if you could maybe tell us what it was like in 2006.
Actually, in 2011, when we decommissioned the shuttle. And as a personal anecdote, I live in Palo Alto, and in that time period, if I would go to a block party and tell people I work for NASA, their response was, "So what are you going to do now that NASA's shutting down?" I said, "NASA's not shutting down," because the public knew you're shutting down space shuttles, so obviously you're shutting down
Everything.
And so, yeah, again, that had a big impact on the agency. Actually, the emerging space industry really started kicking up in 2005, 2006 with this program, Commercial Orbital Transportation Services, COTS for short, that actually we had a big hand at the spaceport and standing up. So Elon was in ascendance in that. In fact, he got his first Falcon 9 flight off in 2010. So we were actually on the commercial space side kind of cheering because the shuttle was out of the way, and now we could have kind of free running space for these emerging space companies. But it's quite disruptive to established organizations going through a paradigm shift, which is what we're doing in the aerospace industry. And these latest flights by Elon show this, and just wait for Jeff Bezos. Elon and Jeff Bezos are in a race to show who is wonkier and more capable. And I'm not sure who's going to win on that, but they're both very capable people. And so it looks like the next few years are going to be just amazing as far as the developments in space. By the way, one thing that they need is surface power for Mars and the Moon, and the only option there is really nuclear. Okay, so and there's also some interest in nuclear-powered propulsion. So I was wondering, does that get around the NRC? I don't know enough about how you do qualifications, but there may be some opportunities there. But yeah, so
Dan just took care of a couple of the questions.
Oh, good.
okay. But at the time, there's times of stress are actually times of opportunities. I love to say a problem is really just an opportunity in disguise, and my colleagues all moan when I say this, but it really is true. Okay, so when you have a difficulty, there's a chance to improve. GM, General Motors, when the Japanese were knocking the U.S. automobile manufacturers out of the park, and they were staring into the abyss of death, that's when they finally had a chance to change. And so, and that's kind of what we're hoping to pull off at NASA. We'll see in the nuclear power industry.
So the first part of the question was about Westinghouse?
Yeah, Westinghouse and what is the future given the problem?
So I actually worked for Westinghouse for over 9 years, left there in August of last year, and I was in their nuclear fuel and R&D areas. Now, what I'm going to tell you is my very personal opinion. It's not that of INL or of DOE, but they have a robust, Westinghouse, I believe, still has a very robust fuel business, a robust services business, and a design business. What you're seeing in the news is their new plant construction segment. And my personal opinion is that the first three areas are going to remain strong and robust and will come out the other end of this just fine. I had worked at the Columbia Fuel Fabrication Facility in South Carolina for Westinghouse. That facility produces the fuel for 10% of the electricity in the United States. So there will be dire consequences if something other than progress happens for Westinghouse in the fuel area. So I personally am quite confident and calm about it. And I encourage you to not extrapolate what's happening, what was a business decision for Westinghouse. I encourage you to not extrapolate that news to the entire nuclear industry. I think that's hitting the panic button too soon. So again, those are my personal thoughts, not that of DOE. Now, the second question was about gain and private industry and should government stay out of it, essentially? Was that right, Per?
Let me see.
Loss of innovation.
Basically.
Loss of innovation. You lost the card. I'll just try some thoughts.
The numbers that I have here are substantial.
Okay, it's okay. So, okay, go ahead. So,
it seems that DOE lost the will, the desire to innovate, to discover. It seems like they were content to sit down and write boring journal articles all day. Is that the case? Is that why GAIN exists? If it is the case, is that okay? If it is the case, should we try and change it?
Okay, so like I said, I worked for Westinghouse. I was in private industry, and the reason I was hired into this role was to change the way things are done. I was actually on the other side, helping form what I didn't know it at the time, but helping form what GAIN was supposed to be. So DOE realized that they needed to change. They realized, and it's a little bit different now with this administration, but they realized the urgency with which we needed to develop more nuclear capability because it was such a green energy source, and realized that the U.S. was lagging behind China and other countries with their nuclear technology leadership. So they came to this realization with the input from a lot of industry, academia, and government. So GAIN was launched because of that. GAIN, the DOE DOE-NE, nuclear energy, has recognized that they need to let industry drive. And DOE needs to be there to support that change. So it's now not pushing out the technology. We're following what industry is pulling us towards.
So why the switch from the 50s when they spun off a new reactor every month to this model?
So the climate in which we operate is very different. And I often say that it's a stodgy industry. It is conservative. Some may argue it's ultra-conservative. And we have muddled along for decades that way. And if we can't sit by on the sidelines anymore. We're getting overtaken by the other countries, right? But the good news is that it's not too late to catch up. To their credit, DOE recognizes that. And they are trying to change the way in which they operate and change behaviors and change culture within their systems as well. And I'm a big proponent of that and a supporter of that because I have been on the other side and have been a customer of DOE Labs. And so I understand what some of my co-panelists have in terms of concerns or frustrations or requests. And I do hope to make some change that way. Does that answer your question? Okay.
So a question here on the education side for Rachel. After the success of Boot Camp Round 1, what do you see as the next steps for moving the new wave of nuclear innovation forward? And a little bit of context, again, from Dan in earlier discussion, pointing out that Jeff Bezos really was interested in rockets, but went out and earned some money first so that he could pursue his interest, pointing towards the value of education and instilling insights and stuff, right? Yeah. But Rachel, could you comment a little bit about nuclear innovation going forward?
Yeah, so I think it's a great question, and it's one that I think we're still sort of striving to answer. Our first step was to expand the boot camp beyond just students, because kind of echoing this need for cultural change, if you just start having a subset of students thinking about things differently, it takes a really long time to change a whole workforce. That is a pace that is too slow, and I'm really tired of hearing that the next generation is going to save whatever it is. That's a long time. So the first implementation with students, just because that was the easiest way to start, really. And so this time we're hoping to start having mid and early career people, so that you start having people who are already in the workforce coming in and getting a little bit of this new cultural thinking. And so I think from the boot camp level, that's the way to start expanding this, is to scale it up to have both knowledge transfer from industry to students to get a practical view, and an enthusiasm transfer from students into industry to help unstick things. In a much broader sense, I don't know if I know what's next. I think seeing actual successes start happening in some of the companies, in some of the government programs, in having getting real traction will expand the need for some of the educational programs and will plausibly get faculty to start rethinking what kinds of projects they take on. I think if we get the funding calls for out of government, which is where the faculty are used to getting their money from, to be more forward-thinking, to be more challenging of norms, to be more integrated with an industry outset, I think that is where the pull to change education really comes from, because only so many people are going to come to the boot camp. But if you actually have people who are starting to work on projects that have a broader view and a more impactful view, that percolates. Now you have a much stronger incentive for change.
Can I add to that? So last July, we had some technology workshops where we actually asked advanced nuclear technology developers to come and talk to us about what their R&D needs were. And the reason why we had it in July was because in August, there is a call for proposals that comes out called CINR, Consolidated Innovative Nuclear Research. And so what those needs did was it influenced the nature of those CINR calls that some of you or all of you hopefully can participate in. And it really crafts those challenge problems to be real world problems, not just something esoteric or sexy to work on, but a real world problem that Jose or Caroline or Ed need to have resolved. And so we plan to continue to do that with a series of workshops, and the timing of those workshops are very, very intentional so that we can start to inform these proposals that come out. You might be familiar with the NEUP, NEAT, those types of proposals. So there is a good connection there.
And correspondingly, the faculty need to be willing to change how they do research. And the faculty need to not whine too much when the calls don't look exactly like how they've always looked. And be willing to maybe take some risks themselves.
We can't whine anymore?
It's one of their favorite
things.
You won't get that.
Oh, no. There's a question here that relates to a part of the strategy for a startup, and this really relates to developing intermediate products before you have, say, a full-blown reactor that you can sell. And is it possible, desirable, to develop technologies, components on the way to full reactor design so as to establish revenue, reputation, etc., before banking everything on new power plants? And I thought maybe Dan might comment from the perspective of space side, and then get perspectives from our three startup companies.
Yeah, I guess if you take a look at the history of SpaceX, it's probably one of the best. Elon was starting with a small-scale launch system, the Falcon 1, that he was actually trying to launch out of an island in the Pacific, out of the Kwajalein Atoll. And that was actually, from the traditional aerospace industry, laughed at. Okay, this is back in 2007, 2008. This was a small rocket he's trying to launch out of an area that we knew there are logistics issues. It's tough to get things out to Kwajalein, okay? And, but what he did, and the reason that turned out to serve him very well, he learned so many important lessons on that smaller scale of integrating all the key systems and trying to get a rocket to fly. And it took him 4 attempts, 3 failures before he finally succeeded in flying his Falcon 1 successfully. But in doing that, then he learned a tremendous amount that actually let him be very successful with the Falcon 9, which is now just blowing the industry out. So yeah, it's very, I think, important, particularly if you're talking about very complex systems, and obviously nuclear power reactors are very complex systems, to be able to do some type of scale and prove out your process, particularly when your design, particularly when you're doing things that are fundamentally new before you go to full scale. One thing I wanted to add on to that, there was a question that, what has Elon done to keep his costs down? And I wanted to mention that one of the things actually he told me directly when he first formed SpaceX, he actually intended it to be a system integration house, that he was going to get his major subsystems from traditional aerospace providers and then integrate them to fly his rockets. And he told me, you know what happens if you ask a traditional aerospace company for a bid on a subsystem? He said, well, what you'll get is something that's obscene in both cost and schedule, okay? But if you agree to that, you're not done, because when it comes time for delivery, you're going to be told, oops, the schedule has slipped and the price is doubled or so, with the expectation that you just pass that along. And by the way, because that's how cost plus contracting works. And so he told me he found that the only way to maintain price control, he actually had to go to a much higher level of vertical integration than he had intended, to get all the way down to the component level where he could get multiple bids, where he would not be held up by a traditional aerospace company. And I found that fascinating. And that's one of the keys for him keeping his costs down, is supply chain control, and all the way down to the commodity or component level.
In terms of innovation and product lines that are developed, I started the company with the free base patents, and we're at 350 patents pending or granted in 20 countries. An enormous amount of innovation happening, in young and old alike. Everybody's working together, and they come up with these great ideas. And some of these are not. Some of these have broader applications than just NuScale. And so potentially, one that comes to mind right now is that we have a very unique module protection system. It's really a gorgeous piece of work in terms of cyber protection, in terms of reliability. It really sets a whole new standard, and it was born of necessity, because we had to be able to control 12 reactors, and we need to do it in a simple way. That's something that could be a separate product in and of itself. So we're looking right now at not just those types of things, but also what services NuScale might provide in the future. There's a whole range of things that, now that we've kind of gotten past the first hurdle of the licensing part, in terms of the submittal, that we can start focusing on those things. And so I'm excited about that potential.
Yeah, so I hadn't heard that anecdote that you talked about, Dan, but we had a little bit of a sense of that, but it was interesting to see that in real life. I don't know how many times we've come home at night and been like, you know what, I think we're going to have to be way more vertically integrated than we thought. The supply chain is really important, and it's not necessarily the sexy part, exciting part, but well, it is for me, but when we're talking about nuclear innovation, a lot of that is the supply chain, really, and there's a lot of interesting things going on for even existing reactors where they can really change how their supply chain goes. So the need for in-stamp parts is going down, and nuclear companies have to be resourceful about how they deal with that. But as far as can we get revenue early on, that's a question that we looked at. Like, is there ways of segmenting off or getting revenue from different parts of what we're developing before we actually build the power-producing thing? And you keep coming back to, what's the goal of our company? We can't have divided goals. And so what that really goes back to is each company needs to be very smart about how they build their milestones, right? Any company, the longer the time scale looks like for you and the bigger the dollar signs, the more innovative and really thoughtful you need to be about, okay, this is the milestone, this is how we plan to raise on achieving that milestone. These are the types of investors, partners, whatever that you're going to raise from at that milestone, and then get to the next one and raise there. So typically you're not looking at getting revenue before you produce your actual product, right? Because that's what you're doing, is producing a product. But there are ways, your revenue looks like investment rounds, and you've got to be smart about how you schedule those and be realistic about how long and how much you think, how long it will take and how much you think it will cost.
I'm always last, so I would echo a lot of what's already said. I think it's true that if you focus on early revenue streams, you can dilute the mission of the company, which is crucial. And so you're always walking a fine line between trying to keep your long-term objectives, but also balance the other side of the ledger, and that's important. And so absent revenues and look at the time horizons, it's a major challenge to be able to do that march without external support. I would say, in terms of revenue streams, I think it depends on the focus of the company and the technology that's being developed. I think if you're focused on the core and working your way outwards, it could be a little bit more challenging to develop certain revenue streams. But if you're taking on certain parts of the problem, that might be more on the balance of plant side, power conversion, or other areas. That does open up potential new revenues. But again, you walk that fine line of trying to dilute what you may be trying to do from a long-term mission. So it's a tough one to answer.
That's excellent. We're getting close to the end of the hour. As I had promised, there are plenty more questions than we can cover in the remaining amount of time that we have. But I would just point out that we've got quite a few young people who are here who are interested in this topic. And so what I'd like to ask each of the panelists fairly quickly is to envision what the future might look like a decade from now. And to ask this question, what should we be aiming for? And I know that Dan's already, he's got this great success story because he started 10 years earlier than we did. But what does that future look like 10 years from now?
On the space side, get ready for big changes. And one of the things I have seen, actually, I noticed this from my kids and raise kids. Kids don't develop just linearly, okay? They go up more like a staircase, okay? You have periods of rapid development and kind of stasis, then rapid development and stasis. And I think that's where we've been, at least in the space industry. We had rapid development in the 60s, incredible, going to the moon. And then we've kind of been in stasis for a while, and I think we're at the verge of another rapid development cycle with SpaceX and Blue Origin and ULA and others. And in 10 years, we could be seeing significant human outposts off-world. Now, the cool thing about that is not just the transportation, but you need power, you need communication, you need security, you need emergency services, you need all these other things that go along with it. And that actually has been one of the things we've been working for, is to open that door to off-world development. And what might that mean for the human condition? And it could be just, transformative. And so, fasten your seatbelts, because it's going to be a wild ride, I think, the next 10 years.
And rapid fire.
So assuming I'm still living on Earth, I think the fact that the DOE culture is changing and the NRC culture is also changing, much in the favor of advanced nuclear technology development. I think, again, my personal opinion, in 10 years, I will probably have a reactor in my backyard powering my house.
I like it. That costs half as much as it does right now.
We definitely need to have multiple NuScale plants up and running in 10 years, that's for sure. And the other part of it is that our mission really is planet, people, prosperity. And I think that this year and in the years to come, we'll be pushing that to better our situation here on Earth.
Yeah, I think there'll be NuScales all around, there'll be Oklos all around, and hopefully with the first, couple advanced reactors getting through the regulatory process, it'll be very rapid for everybody else. So it could be very different 10 years from now.
I would say in the 60s and the 70s, we thought we were going to build 1,000 plants. That didn't happen. In the 80s, we thought we were going to build 0 plants, and they were all going to shut down. That didn't happen, so I don't think anybody really knows what's going to happen in 10 years, but it could be very different from what you think now. So.
Let's plan that everybody here is going to work on creating that future, that we're going to take the insights that come from ingenuity and from looking across broad-ranging disciplines and apply them to make these advances, and we will believe that we can be successful if we think outside the box. So I'd really like us to thank our panelists for their excellent insights.